Hello, my name is Nick Ingram. I'm going to be demonstrating today how to perform addition and subtraction between the four number bases. Right now we're going to start off with decimal or base 10 number base, and we're going to perform addition. It's 342 plus 289, so let's get right into it. So first we're going to get 2 plus 9, and then that's going to equal 11. We carry over the 1. Basically, we're adding this 1 to the 4, and that's going to make it a 5. We're going to treat it like 5 plus 8, which equals 13. Carry over another 1, and then that's going to be 4 plus 2. So we get 631 for our first answer. And then for subtraction, it's a little bit different, but we're basically sticking to the same concept. We're going to look a little bit ahead here and see that we need to subtract 3 from 9. So we're going to borrow 1 from 2. That results in 0, so we're just going to mark that out for now. This is going to be treated as 13 minus 9, but then we also have that 1 minus 8, so we're going to treat it as 12 minus 9 and 11 minus 8. So we're going to get 3 right here, and then 3 right here. So 231 minus 198 equals 33. So the second number base that we're going to be demonstrating addition and subtraction on is going to be binary. You could see that it's a base 2 number because we're only demonstrating it with zeros and ones. It's a little bit more tricky, but we're going to demonstrate that right now. So we're going to get 1 plus 1, that's 2, so we're going to put that as a 0, carry over a 1, 0, which equals 2. We're going to have 1, 0 plus 1, so we're basically just going to go down here, do another 0, treat this as 2. Then once we get 0 and 0, we drop the 1. Then we have 1 and 1 again, 0. Carry over 1, 0. And then this is going to result in carrying this over once again, right here. And then we're going to demonstrate this by converting these to their decimal counterparts. And we're going to have the answer. So we're going to have 1 plus 2, making it 3. Plus 8, that's 11, plus 32, and that's going to be 43. The second one is actually going to be 1 plus 2 plus 8, so that's 9 plus 16, resulting in 25. Then after adding these together, we're going to get 68. So let's double check its decimal counterpart right now. So we don't have 1, we don't have 2, we have 4, no 8, no 16, no 32, but 64. So 64 plus 4 equals, well, you guessed it, 68. All right, so now we're just going to be performing subtraction right here for our binary number. So we get 1 minus 0, we cut that out, we borrow it over here. I'm going to put down a 0 just to keep track of our bits. We drop down the 1 because 2 minus 1 is, you guessed it, 1. We drop down the 1. We don't really see where we would need to borrow another 1 anytime soon, so we're just going to drop it down. For this one, however, we do. So we're just going to cancel this out, put a 0, and then we're just going to put our 1 over here, drop down another 1, and then 0. So now we have 0, 1, 1, 0, 1, 0. I think that looks correct, but we're just going to double check it again with their decimal representations. So 1, 0, 1, 1, 0, 1. So we're going to have 1 plus 4 plus 8, not 16, but 32. So we're going to have 45, and then we have 1 plus 2, 4, 8, plus 16. So we're going to have 45 minus 19. Now we're going to borrow that. It's going to be 20. 15 minus 9 is going to be 6. So we have 26 for our answer. Now we have 2, 8, 16. That's 24 right there, plus 2. That's going to be 26 in binary. All right, so What we're going to be demonstrating now is hexadecimal numbers. That's a base 16. Basically from 0 to 9, it's just represented as regular numbers, like you can see right here, the number 4 and the number 5. But then after we reach 10, we start representing with letters. It's just really the easiest way to represent them without creating any new symbols. So for A we have 10, B we have 11, C 12, and so on and so forth up until F equals 15. So right here we're going to start with CF 7 plus 49D. 7 plus D, that's going to be 7 plus 13, and that's 20. So we're going to, oh, my apologies. We're just going to have an extra of 4, because, 20 minus 16 is 4. We're going to carry a 1 up here. That's basically 16 plus 9. It's 25. That's about 9 over. That is 9 over. We're going to carry the 1, so it's going to be 12 plus 1 plus 4. That's going to be 13 plus 4, 17. So we're going to have 1 left over, and then we're just going to carry another 1 over. So we got 1194, base 16. All right, so now we're going to be doing subtraction for hexadecimal numbers. So we're going to look at our problem first. We're going to notice that C minus 4 is going to be okay, but 4 minus F, not so much. So what we're going to be doing is we're going to borrow 16 from C. So we're going to just make that B real quick. We're going to add 16 to 4. Effectively, that's 20. And then 20 minus 15 is going to have a remainder of 5. And then E minus 5, that's going to be all right. That'll just result in 9. And then we have B minus 4, and that'll just be 7. So 759, base 16. All right, so now we're going to be working with octal. It's a little bit more simple than hexadecimal. It's a base 8 number, meaning we're going to range from 0 to 7. So first we're going to demonstrate addition using octal numbers. So 5 plus 2, that's going to equal 7. 4 plus 6, that's going to equal 10, but we need to carry that on. So we're going to put the remainder of 3 right here. Add 1 up here. That's effectively going to be resulting in 11. And then 1137, base 8. Okay, so now I'm going to demonstrate subtraction using octal numbers. Now the first part, we're going to need to borrow. This is going to be 5 minus 7. That just simply doesn't work. So we're going to change this to 2. And essentially we're going to add 8 to this 5, making it 13. And then 13 minus 7 is going to result in 6. Now with this 2 minus 4, it doesn't work either. So what we're going to do is borrow from the 7, make that a 6. And then we're going to add 8 to the 2, making it 10 minus 4. That's going to result in a 6. Now 6 minus 6, that just cancels out to a 0. So there we have it. 735 and minus 647 in octal results in 066 base 8.